Hello, this is Kenny Belfato at SimTech, and I'm showing you our SimTech software, CIM-TECH.com. That's our web page and our great history here. The software's been out since 1986, and it's integrated CAD CAM right inside of AutoCAD. So I've got my AutoCAD loaded here, and I want to use a tool called Multi-CIM that's going to take these individual parts and turn them into individual drawings for me. So it's going to W block them out as separate drawings. Put the outside on layer outside. I put the holes on a layer called hole. And the way the multi-sim works, it just looks at this layer name, and with the pick of a button, it just turns all those into individual drawings for us, and there they are. Now I could have text inside each one of these parts that has the part name and the material name and the quantity. If not, it just starts numbering them right there. Now this cut list that it made has the name of the part, the material, and the quantity. So it's basically just a drawing name, the material, and the quantity, and there was just one of each. And it calls it no material, but that's a valid material for us. Basically have that set as a 4x8 material. I could right click on a cut list and pick cut with Router Sim Automation Suite, and the rest is automated. It'll open up each part, make the single part program, and then nest the parts together. So this is building a job right from an Excel spreadsheet or from a cut list like that. Any kind of Excel file or CSV file, we can make toolpaths from those directly. And that's what's happening here. It's going to start up AutoCAD, look at each piece, look at the layers that it's on, make a toolpath, make the program for it, and then make a nested sheet with all those parts nested together. There's a little summary report that happens for each part as well. And when this is done, we'll have the individual programs and then the NC code files. Now, when we nest parts, we can nest by price or by yield. So I could put in alternate stock sizes. And in this case here, we're also getting skeleton cuts, so I can have the software automatically chop up the remnants for us. That's what those lines are right there. And looks like it's going to take these two sheets and sequence those together and make us the NC code file. And the whole operation was done in just a few clicks. The results have labels and reports, individual programs. So I've got each of my individual drawings with their toolpaths on them. I've got the NC code files for each of the 20 individual parts. That's to run the part by itself. Then I've got the 2 sheets of G-code file or whatever NC code file we need. It saves the nest drawings. You can modify it using AutoCAD commands. You can make changes to these nests. This is what's called the tool stay down nest. So the tool stays down and connects from part to part without lifting up. This is a way to reduce cycle times. So there's just one lead in and one lead out. And the parts have a little overlapping bridge that connects them together here. So the tool goes past where it starts. So you don't get a bump on the part. There's a little overlap there. By keeping that tool down and connecting part to part without lifting up, it reduces the overall cycle time. Makes it a lot shorter cycle time. The other thing in here is all of your labels. So it makes labels for all your parts. You get a full labeling program included with the router sim. And you can customize the labels, put whatever information you want on the labels. And the other information in there is a summary report. There's a simulation here as well. It shows the tool removing the material. And you can reset that and change the speed here and let it play. So you can see it did the drilling operations first, and there's the tool stay down operation, connecting part to part without lifting up. And then the skeleton cuts to chop up the remnants. The other thing in here is your a summary report that has that saves it as an Adobe file, a PDF, and it puts it in an Excel spreadsheet too. But this is basically your cycle time for each sheet and the cycle time for each individual part, and then what kind of material yields you got and scrap areas. Puts that into an Excel spreadsheet or a PDF file. All of these results are in a folder with the same name as the original drawing, and it's ready to run at the router in just a few clicks. Thanks for taking a look.